This is problem number 6 on the section 5X quiz. It says Sandra deposits $3,000 at the end of each semi-annual period for 14 years at 12% interest compounded semi-annually. Find the amounts you will have on deposit, round to the nearest cent. So the thing you have to read into this when you're solving these problems and they're all mixed together, the first thing you've got to decide is it a single deposit left for a certain period of time and that's it, or is there a periodic payment involved? Now here she's going to deposit $3,000 at the end of each semi-annual period for 14 years. So that's a periodic payment. Even though they did not say the word periodic payment or the phrase periodic payment, that is a periodic payment. She's putting it in twice a year for 14 years. So this is an annuity problem. So you need to immediately jump to that and realize that you need to write down the formula for the future value of an ordinary annuity. So that's the very first thing. If you get this formula incorrect, you're sunk. Just to be complete, I'll write down what all these things are. S is the future value of the annuity. Capital R is the periodic payment. Little r is the annual interest rate. T is the number of years, or the time in years, if you'd rather say it that way. This little I is the interest rate per period, which is calculated as the annual interest rate divided by the number of compounding periods in a year. So in this particular problem, R is 0.12 and M is semi-annually means M is equal to 2. Of course, R is 0.12. So you get, and you can probably do that in your head, an interest rate per period of 0.06. And then little n is M times T. Since M is 2 and T is 14, that of course means that N is 28. So now we can start solving. She deposits $3,000 periodically, so that's capital R. We want to know how much you will have on deposit at the end of this time. That's your future value. So we have S equals $3,000 times this big fraction, 1 plus, again, little I is 0.06 raised to the little n, which we calculated to be 28. Subtract 1 from that and divide by 0.06. So we now know that the future value is 3,000 times, and as I've said before, I'm going to show more intermediate steps than you probably will. You can leave a lot of this in your calculator, but I can add 1 plus 0.06 in my head, so I'm not going to make a big deal about that. But I will take the 1.6 and raise it to the 28th power here so you can see it. So I've got 1.06, the power button right beside the MR, to the 28th equals, and that's this 1.06 raised to 28th power. You can just leave that in your calculator and not write it down as an intermediate step, but I want you to have something to look at in case you're trying to fix an error that you made. So I'm going to write this intermediate step down, even though you might choose not to. If you do write it down and use it that way, you need a lot of decimal places so you don't lose accuracy to the nearest cent in the end. So the future value is 3,000 times this fraction. Now I already have part of this in the calculator. I have that 5.11 number in there. So all I've got to do is subtract 1 and subtract 0.06. So I'll take that now and I'll subtract 1 equals, and then divide by 0.06 equals, and that gives me the multiplier for $3,000 is 68.5281162. So I've got 68.5281162 if you round it off to that place. Now all I need to do is take that product, and the number is already in the calculator. So I just do times 3,000, and there we have it. So the future value of that ordinary annuity is $205,584.33.